Now, immunity describes the ability of the body to resist infection. So all over the surface of our bodies, all throughout the gut, all over the surface of everything around us, all over the surface of the earth, under the earth, up in the air, anywhere you look, there's going to be bacteria and viruses, potential infections. So we have to have immunity, the ability to resist infection. Now, infection means that microorganisms are growing in a tissue of the body. It can be a local infection, like an infected cut, or it can be a systemic infection causing severe sepsis. So, infection is microorganisms growing inside the body, and the immune system resists that. It prevents infection from developing, and if infection does develop, it will counter that infection, it will fight that infection. So immunity, as the ability to resist infection, is absolutely vital to life. So immunity typically is divided into two types. And the first one is innate or non-specific immunity. Now, this describes the many aspects of immunity that we possess as a result of our anatomy. For example, intact skin and intact mucous membranes. It is innate by virtue of our biology. It is not something which has to be learned specifically. And innate immunity is non-specific. This means it works against a very wide variety of potential infecting organisms. So intact skin, for example, can keep out worms, it can keep out fungi, it can keep out bacteria, many different millions of types of bacteria it can keep out. It can keep out viruses. It works in a non-specific way against a large variety of potentially infectious agents. So it's innate, everyone's got it as long as they're healthy, and it's non-specific. It doesn't have to be learnt. It acts against a very wide variety of potential infections. Now, the other classification of immunity is acquired immunity. And acquired means at one time we did not have immunity to something, and then we acquire it. We pick it up. It's like anything else. I maybe didn't have a computer, then I acquire one. I now have one. So it's acquired. It has to be picked up. So we don't start with this, we pick it up as we go along. And the other thing about acquired immunity is it's specific. It is specific to a particular type of infecting organism. So if you develop immunity to a cold virus, you may not have immunity to an influenza virus, because the immunity you develop to one virus is specific to that virus. If you've had an influenza virus, that doesn't stop you getting another type of virus, a herpes simplex virus or a human papilloma virus or whatever virus it happens to be. The immunity is specific to one type of virus or one type of bacteria. So if you've had one type of bacterial infection, that doesn't make you immune to getting another type of bacterial infection. The immunity is specific to a specific infecting organism. So it's acquired, you have to pick it up, and it is specific. So this one is not acquired, it's innate. This one is acquired. This one's non-specific, it acts against a wide variety of organisms. This one is highly specific, only working effectively against one specific organism. Now, acquired immunity, there's different types of it. And the first one is active. Now, acquired specific immunity depends on specific immune proteins being present in the body. The immune system has to recognise the specific infection, that's called the antigen, and as a result it produces a specific immune protein called the antibody. This is how it works. So in active immunity, your own immune system or my own immune system has made the antibodies itself. So I'm exposed to a virus or a bacteria, my immune system makes the antibodies, and that gives me active, specific, acquired immunity, because I've made the antibodies myself, and after making the antibodies, I now enjoy the immunity to whatever it is I've made the antibodies to. But acquired immunity can also be passive. Now, passive immunity is where you can enjoy, or an individual enjoys immunity from particular infections, but they have not made the antibodies themselves. Someone else has made them for them. So how can this arise? Well, babies are born with their mother's antibodies already in the baby's blood. So mum, throughout her lifetime, has come into contact with various organisms. As a result of this, mum has made antibodies. She has immune proteins. During the later part of pregnancy especially, many of these immune proteins migrate from mum's blood into baby's blood. Transplacental transfer of antibodies. They go through the placenta from mum's blood to baby's blood. This means when baby's born, baby's got all the antibodies in their blood that mum had. And that means that although the baby comes into this bacteria and virus-ridden environment, they have immunity to it. Otherwise, all babies, if it wasn't for this, would die of infection straight away because they would have no immunity. They've had no time to generate their own active immunity. So they get it from their mums. And also when they take the first milk, the colostrum, before it's even really milk, that's very thick, serous type fluid, the initial milk that is produced during lactation, the initial fluid in lactation. And that's very rich in antibodies as well. So they drink in mum's antibodies. And there's more antibodies present in the milk as well. That's why initial breastfeeding is so important for babies. They get lots of antibodies from the colostrum, and then they get more antibodies from the milk. So as well as getting the optimum form of hydration, the optimum form of nutrition, they also get immunity, making it much more likely they're not going to get infections in early life. And sometimes, we don't do this very often these days, but we can give injections of gamma globulin. In the old days, before we had hepatitis A vaccine, for example, you used to give injections of gamma globulin. And this will give people a degree of passive immunity to hepatitis A. But the antibodies that you inject don't hang around in the blood for that long, so the immunity doesn't last for very long, probably only 2 or 3 months at any effective levels. So the main way is transplacental, colostrum and milk, and occasionally we'll give injections of antibodies. So an individual comes to enjoy immunity, but they haven't had to bother making the antibodies themselves. And this is particularly important in babies because it gives rise to what's called active on passive immunity. So the baby's enjoying passive immunity because they've got mum's antibodies, and then they're exposed to a particular infection themselves. Now the baby doesn't get that particular infection because they're immune, because they've got the mum's antibodies, which is great. But it also means that the baby's own immune system is exposed to that antigen, that virus or bacteria or whatever infection it is. They're exposed to it, and as a result of that exposure, they will make their own antibodies. They will generate their own long-lasting active immunity. Because passive immunity is short-lived, it only lasts for a few months, whereas active immunity can last for decades, or even for someone's whole life sometimes with some infections. So the acquired specific, active if you make it yourself, passive if you get it from someone else. But that's great because it gives you time, if you're enjoying passive immunity when you're a baby, to make your own active immunity as a consequence of that. So antigens are anything the immune system recognises as being foreign, like a bacteria or a virus. And the antigens stimulate the synthesis of the antibodies. The antibodies are the immune protein that implement specific acquired immunity. And antigens is short for antibody generating molecules. So antigen. antibody generators. It's the antigens, that is the infections, that generate the antibodies. So antibody generating molecules stimulate the synthesis of antibodies.